Hello everyone, I am Sham Parik. I am a student of BSc Chemistry Honours first year. My roll number is 10 and today we are going to read the chapter Liquid Crystals. In some crystalline solids, the tendency of the orderly arrangement is such that on melting the solids do not give liquid substance directly. Instead, they first pass through an intermediate state called the mesomorphic state or paracrystalline state. The intermediate state is often referred to as liquid crystal, which one further heating undergoes a transition into a clear liquid. This intermediate state, liquid crystal, exhibits characteristics of both solid state as well as liquid state. Thus, the crystal liquid is intermediate between the solid state and the liquid state. Liquid crystals are neither liquid nor solid. They have some properties of crystalline solids. Liquid state depicts random arrangement of molecules which allow them to move over one another. In a crystalline solid, the molecules have an ordered arrangement and fixed position. Whereas in liquid crystals, the molecule can flow over one another while maintaining their proper orderly arrangement. One such compound that forms liquid crystals is peroxoxyanisole. When solid peroxoxyanisole is heated, it melts sharply at 389 Kelvin to form a turbid liquid, which at a higher temperature, 408 Kelvin, turns sharply into a clear liquid. These changes may be represented as solid P peroxoxyanisole when heated at 389 Kelvin gives liquid crystal, and then at 408 degree Kelvin it becomes a liquid. The first temperature at which the solid changes into turbid liquid is known as transition point, and the second temperature at which the turbid liquid changes into clear liquid is known as melting point. So in case of peroxoxyanisole, the transition point is 389 Kelvin and its melting point is 408 Kelvin. On cooling, these changes take place in reverse direction at the same temperature. The turbid liquid show anisotropy. This is a property of crystalline solid according to which the properties like refractive index, thermal and electrical conductivity, etc. are dependent on the direction along which they are measured. Liquid crystals show anisotropy in their optical properties like refraction. Hence, liquid crystals resemble crystalline solids except for the anisotropy and refraction. The liquid crystals behave like true liquids. For example, they possess surface tension, viscosity and ability to flow. Hence, some other names like crystalline liquids, anisotropic liquids and paracrystals have been proposed. The most suitable name for this state is mesomorphic state, means intermediate form. However, the term liquid crystals is frequently used. Classification of liquid crystals. According to the molecular orientation, the liquid crystals are classified into three types. Nematic liquid crystals. In the nematic state, the molecules are arranged with their long axes parallel to each other and they are free to roll or slide individually. As a result, they are less turbid and can flow easily. These molecules are not arranged in layers. Shows the arrangement of molecules in nematic liquid crystals. Show nematic state. The planar structure is not present. In this state, the molecules tend to organize themselves in parallel fashion, and due to this property, they exhibit useful optical properties. They scatter light strongly. Nematic liquid crystals are used in liquid crystal displays (LCDs). Some examples of compound forming nematic liquids are peroxoxyanisole, peroxyphenol, peromethoxycinnamic acid. Semitic liquid crystals. The word semitic is derived from Greek word which means soap-like. The molecules in the semitic state are also parallel, but these are arranged in layers. The molecules are arranged in well-defined planes and they flow in layers as if different planes or sheets are gliding over one another. The symmetric state is more like solids. These liquid crystals do not flow like normal liquids. They have high viscosity and are less mobile. When spread on a clean glass, they form series of stepped terraces. This suggests that their structure consists of series of planes placed one above the other. The molecules have the long axes parallel to each other and are arranged in layers. These layers slip over one another. Their structure is supported by the fact that the symmetric liquid give X-ray diffraction patterns only in one direction. Some examples of compound forming symmetric phases are ethyl peroxybenzoate, ethyl peroxycinnamate, ammonium oleate, etc. Cholesteric liquid crystals. Some liquid crystals such as cholesterol esters show in addition to the nematic behavior some color effect when placed in polarized light, so they are called cholesteric or chiral nematic liquid crystals. In cholesteric state, the molecules are parallel as in nematic state but are arranged in layers. The molecules in the successive layers are rotated at small angles to one another. Thus, the angles between these planes change slightly and they form helical structure. Due to the helical structure, this liquid crystals show special optical properties. They reflect light of different colors at different temperature. When these liquid crystals are subjected to temperature change, the distance between the layer of the spiral also changes. This results in change in pitch length. A particular pitch length corresponds to a particular wavelength of visible light. Therefore, the color of the reflected light changes accordingly. So, cholesteric crystals. So, series of color change with change in temperature. These liquid crystals are used to monitor the change in body temperature and to locate areas of overheating in machines. The rings used using coloristic liquids are used to study variation in person's mood. These rings change their color as the body temperature varies with mood variations. Uses of liquid crystals. Liquid crystals are used in electronic digital display instruments such as digital wristwatches, calculators, etc. They are used in industry as lubricants. Pneumatic liquid crystals are used for liquid crystal display devices (LCDs). These are used for detecting tumors in the body by using a method called thermography. These films or coloristic liquids are used to map the skin temperature and diagnose the diseases tissued in the body. Substance showing both somatic and pneumatic characteristics. Some substances on heating show this three phases changes instead of two. For example, cholesterol myristate on heating metal melts sharply, melts at 72 degrees Celsius to give somatic liquid crystals. The somatic phases changes sharply at 78 degrees Celsius to give pneumatic type crystals, which in turn melt sharply at 83 degrees Celsius to give a clear liquid. These changes are represented as cholesterol myristate. Crystalline solid at 72 degrees Celsius becomes liquid crystal, and at 78 degrees it becomes again liquid crystal from somatic to pneumatic, and at 80 degrees Celsius it becomes true liquid. The compound evidently shows two transition points and one melting point. Differences between liquid crystal, solid and liquid. Solid represents a perfectly ordered state having long range order, whereas in liquids the long range order does not exist. Liquid crystals represent an intermediate state between solids and liquids, so mesomorphic state or liquid crystal do not have perfectly ordered arrangement like solids, but there is more order than in the liquid state. X-ray diffraction studied of liquid crystals show more ordered in liquid crystal than in liquids. Liquid crystals flow like liquids even when their molecules are arranged in an orderly fashion. Liquid crystals are not crystalline, they possess surface tension, viscosity and ability to flow like true solids. Some solids on melting give somatic type liquid crystals, while some give pneumatic type liquid crystals on melting. In both the types of liquid crystals, there is less order than the crystalline solids, but the molecules in them are more ordered as compared to liquids. However, there is more order in somatic liquids crystal than in pneumatic liquid crystals. Some solids on melting form become both types of liquid crystals. For example, cholesterol myristate is a crystalline solid. On melting up to 72 degrees Celsius, it forms a turbid liquid called somatic phase. On further heating up to 78 degrees Celsius, the turbidity decreases and a new phase called pneumatic liquid crystal is formed. On heating further up to 83 degrees Celsius, the melting point of cholesterol myristate, a clear liquid, is formed. These changes may be represented as follows. Crystalline solid cholesterol myristate at 72 degrees Celsius becomes pneumatic liquid crystal, and about 78 degrees Celsius it becomes pneumatic liquid crystals, and about 83 degrees Celsius it becomes true liquid. The structural differences between crystalline solid, liquid crystal and pure solid is shown diagrammatically. Again, let us take the example of cholesterol myristate. In crystalline solid form, there is a long range order extending throughout the crystal figure, that is, the molecule are arranged in a regular definite pattern in all the three dimensions in crystalline solid. When solid cholesterol myristate is heated up to 72 degrees Celsius, it forms a turbid liquid which is somatic liquid crystal phase. In this phase, the molecules arrange themselves parallel to each other in equidistant planes, but their orientation within the planes is irregular. In this phase, the long range order of solid state does not exist. However, there is more order as compared to liquid state. On further heating, the turbidity decreases, and at 78 degrees Celsius a new phase called pneumatic liquid crystal is obtained. In pneumatic phase, more disorder is introduced. The molecules are orientated in parallel planes, but these planes are not equispaced. But even in pneumatic phase, there is more ordered arrangement of molecules as compared to liquid state. On heating the pneumatic liquid crystal up to 82 degrees Celsius, the clean liquid is obtained. At this temperature, more disorder is introduced in the molecules and liquid state is obtained. In this state, only short range order is present. Thermography. Thermography is a method of recording the temperature variation, especially of the skin, on a temperature time graph. Cholesteric liquid crystals are used for thermography. This is because these crystals show special optical properties of reflecting light of different colors at different temperatures. The property arises because of the helical structure of cholesteric liquid crystals. These liquid crystals have special optical properties which depends upon the temperature variation. It is observed that they reflect light of different colors at different temperature. It is due to the fact that when these liquid crystals are subjected to temperature change, the distance between the layers of the helix changes. In other words, the pitch length changes with change in temperature. A particular pitch length corresponds to a particular wavelength of visible light. When this pitch length changes with temperature, the color of emitted light also changes. However, there is no change in the chemical structure of the cholesteric liquid crystal. Different liquid crystals scatter visible light at different temperature. Their optical behavior is described in terms of event temperature and clearing point temperature. The event temperature is the lowest temperature at which the liquid crystal scattered visible light, that is the lowest temperature at which the liquid crystal starts reflecting the color. Also, at the temperature below the event temperature, the liquid crystal exists in solid state but will appear transparent, that is, it will not scatter visible light and hence reflect no color. Whereas the clearing point temperature is a temperature above which the liquid crystal becomes pure liquid, that is, it does not show the properties of liquid crystals above clearing point temperature. To sum up, we can say that a liquid crystal shows optical properties between the event temperature and clearing point temperature. Below event temperature it is solid and above clearing temperature it is pure liquid. So in thermography the suitable liquid crystals are selected depending upon the colors of the light reflected in the required temperature range. Thermography has found widespread application in the medical field. This technique is used in early detection of tumors such as breast cancer, in the detection of orthopedic disorders like back pain, arthritis, etc. The principle underlying the detection of disease is the fact that the produced in the is that the that the heat changes produced in skin above the disease organ are different from the heat changes under examination. Now this crude method is not used. In the advanced method, the liquid crystal are pressed against the diseased part as well as the healthier part of the body, and the colored photographs are taken. These colored patterns are interpreted to detect the diseased part of the body. Liquid crystal display at 7 segment cells. Liquid crystals find wide application in the electronic industry. Both metic and nematic type liquid crystals are used in electronic equipments as a device called liquid crystal display (LCD). LCD screens are widely used in digital watches, cell phones, calculators, etc. A liquid crystal display (LCD) is a thin, lightweight display device without any moving parts. It is named so because the display screen is made with the help of liquid crystals, both metic and nematic type. The principle of LCD is as follows. In a LCD, a very thin film is placed between two polarizing sheets. These are glass sheets coated on one side with some conducting material like tin oxide. When no current is passed through the polarizing sheets, the molecules are uniformly orientated and the light can pass through the shell. This is because the molecules of the liquid crystals are in relaxed state or lower energy state, and this entire assembly appears transparent. When an electric field is applied, the molecules present in the liquid crystal twist into an excited state, causing the light to get scattered. This results in a black display on the screen. Thus a number or a letter is displayed in black color against a silver background. A liquid crystal display can be made of any size and is cheap in cost. It uses very small amount of energy to give images, so watches, calculators, etc. can be operated for very long time without any battery replacement. The clarity of the image produced by LCD is greater because of black image imposed on a silvery black background. The amount of luminance produced by normal LCD is usually given in nits. The brightness of luminance produced by normal LCD is up to 200 to 300 nits. 7 segment cells. LCD screens and display watches and calculators, etc. are composed of several 7-segment sections or 7-segment cells. Each of these cells can display one number as shown. Different segments can be separately used to collectively show one number. This concept can be extended to any number of digits with use of more and more number of 7-segment sections in a series. Similarly, for alphanumeric display, 14 segment cells are used. Each segment is an active area in the display in an LCD screen. The diagrammatic representation of a complete display panel is shown. It consists of two polarizing sheets. The polarizing axes of two sheets are aligned in same direction. These polarizers transmit light in perpendicular direction. A layer of liquid crystal is placed in between these polarizers. A mirrored surface is placed to reflect the light coming out of the polarizing sheet. In the absence of electric current, all the liquid crystal molecules are aligned uniformly. Therefore, the light passes through both the polarizer and is reflected back at the mirrored surface, and again it passes through both the polarizer. As a result, the entire panel appears silvery. On passing electric current, the molecule in the liquid crystal becomes disorientated and the axis of polarization of light gets rotated. Thus, the light coming through the first polarizer gets rotated by passing through the liquid crystal, and it does not pass through the second polarizer. The result is that this results in a dark image on the screen. Color display. The liquid crystal uses in LCD rotate all visible wavelength to an equal extent, so the image is seen as black against silvery background. Now refinements have been added to the basic LCD to produce color. In a color LCD we use pixels instead of 7 segment sections. Each pixel is divided into 3 sections via one with a red filter, one with blue, and one with a green filter. The pixel can be made to limit a particular color by varying the relative brightness of these 3 color sections. All the pixels, when used collectively, give a sharp, bright and colored image. So this was all about our liquid crystals, and here we have read about the 7-segment cells and about the principle of LCD, the liquid crystal display in the 7-segment cells, and then we discussed about the thermography, and after that we read about the difference between liquid crystal, solid and liquid, and then we read about the uses of liquid crystals and and coloritic liquid crystals, and about symmetric liquid crystals and nematic liquid crystals, and this was the classification of liquid crystals. So this was all about our video of liquid crystals. Thank you all for watching.